my car. So I'm showing you my engine bay right now, and I'm going to talk a little bit about the engine. It's a 2.0 liter base engine size with a double overhead cam. It's an inline 4-cylinder, 16 valves, 207 foot-pounds of torque at 1800 RPM, a stock 200 horsepower at 5,100 RPM, and a turning circle of 35.8 feet.
You are now about to witness the strength of street knowledge.
This is my dad's 2008 Toyota Tacoma. It's got 5 seats, 236 horsepower, and 266 foot-pounds of torque. It is 221 inches long and 74 inches wide. We're gonna launch it, Fagan.
Alright, so Nick, explain some physics right now.
Alright, so as you can see, for those 2 videos that we did in the launch test, there's a very big difference when obviously taking off on a dirt road with rocks versus a residential paved road. As you can see with JT, when he started his launch, his tires got spinning in the wheels, which led to but it also depends on the type of tire and size of tire that you have. It also depends on, how big your tires are, the tire radius, winter versus summer for sport tires. Obviously with JT's truck, the tires are made for off-roading, so he had better handling than John's Saab, which had all-season tires on, and they had a lower tread than JT's. So that results in what just happened. Back to the car launch time, since GT's car is obviously, or truck is obviously bigger than John's, the smaller sedan, the launch time was a huge difference compared to John's car due to the size of the vehicle and the weight of the vehicle. One of the videos that we took, we saw that GT's car obviously took longer compared to John's 0 to 60 times, so that's what we calculated.
Nick's going over the speed limit. His smaller car, more powerful engine allows him to do this. He is breaking the law, Fagan. I didn't tell him to do this. There he is.
Stop, drop, shut him down, open up shop. Oh, no, that's how rough riders roll. Stop.
Car revving, the more you rev, say if you want to take off really quickly, which will increase your acceleration, which relates to Newton's second law of force equals mass times acceleration. Since my car is a coupe, it's weighs less, it's going to have a larger acceleration, which is going to equal into a greater force. So I'm going to show you an example of me revving my car.
According to Newton's third law, every action has an equal but opposite reaction. So does pressing on the gas pedal. gas pedal, his engine did things and converted the energy to kinetic energy, pushing him forward and accelerating his car.
Yeah, so when I started like from the 0 to 60, there's a lot of potential energy that was built up in the engine before I pressed on the gas, and that potential energy was converted into kinetic energy, otherwise known as motion. The harder I pressed down on the gas pedal, the faster I went, which meant that obviously there was a greater increase in motion.
Alright, Fagan, as you can see, can't really launch here because of the traction difficulties these holes caused and the gravel combined. If I were to go faster, I would lose control easily, so I have to go slow and can't launch.
Another thing about the truck, obviously they have a better suspension system in a situation like this. You know, for like heavy duty trucks going through mud roads or rocky roads, because they're just they're gonna be like used to these conditions. So that's why GT's truck is handling really well right now at the speed that he's going, and we're having no trouble getting through these bumpy roads.
If Nick were to do this, his car would not be able to handle it because it was lower to the ground. His tires don't have as much tread on them, and the suspension wouldn't be able to handle this.
I definitely would bottom out way more easier than GT due to my suspension. That's why I never want to bring my car here into the meadows. So this is a demo clip of what we just talked about, of how GT's suspension handles up in the truck. And as you can see, he just went over those bumps in the rocky road very easily. The difference in tread on the truck and my car. So to give you a little background story of what traction is the friction between wheels or tires in the ground that allows the vehicle to move forward. It is also the resistance to spinning when a torque is applied to a wheel and axle. Obviously, the higher the torque,